Let's talk about LeetCode 138, copy list with random pointer. The question asks us to have a copy with a linked list. For this kind of linked list, it has three kind of properties. One is value, one is node, next, which will reference to the next node. And it has another property, which is random, which will pointing to some other node. So for this question is that we iterate this linked list. When we iterate, we create a copy of each node. And also connect the next pointer for it. And also what we do is that we use a map. The key will be the original node, and the value will be the copy nodes. And then we iterate the node again. For each node, we find it's the random pointer pointed nodes. And for this nodes, we have find its copy, and this node find its copy, and use a random reference to connect them. So let's write code. If 8 equals 9, just return 8. We are going to use pointer current equals 8. And I'm going to have a copy with this node, which we call current copy equals new node 8. And we need to have a map node map new hash map. But the key will be original node, and value will be the copy node. So let's iterate the node, the linked list. One and node. Current equals current next. And also current and equal to none. Yeah. So current equals current next. We can write this current next and equal to now, and the current equals current next, so that it will stop at the tail. And we're going to have a copy. Copy equals new node current of the value. New copy. And we will have the current copy of next equals new copy. And we also need to move current copy equals current copy with next. So in this case, we create another copied linked list. And when we copy this, we need to put this one into map. That is map put and new copy. So that's the first step. We create another linked list, and we also put for each node we have a map for it. So we need to iterate again. Let's have this one to be the head again, and current copy equals map. It so we need to find this random while current equal to no current next, and we need to have a random node random node equals current dot random. And we need to find the node that is random copy equals map it random node. And we need to have a current dot random equals random copy. And in the end, we need to return a map it a. And head current current copy current equals head current. Oh, this should be what we should have the map with current dot random. And also and for this one, whether we move doesn't matter because we already get use this way. Of course, we can use the current copy dot random equals and have this one move again. So this first way we use a map to it, and for the map, we iterate the linked list. So it is O(n) time complexity, and we use a hash map. So the space is also O(n) time space complexity. For this question, we have some beta method. That is, we'll do the second way to do this. Let's talk about the second way. So we see this example 7 pointing to 13, and let's get to this one. shift to the left. So let's say 7 pointing to 13, and 13 pointing to 11, 11 pointing to 10. So what we are going to do for the second method is that I'm going to copy each node. Instead, let 7 its next pointing to 13. I'm going to insert these new nodes in between 7 and 13. So 7 is going to pointing to copy the 7, and copy the 7 while pointing to 13. In the 13 nodes here, here, here. And then in the end, there is 10, and may pointing to now. So this is the first step. For each node, we have a copy and insert after the original nodes. So this is step 1. Step 2. Step 2 is that we copy the random. For example, the 7, its random is pointing to 1. Okay, we don't have 1. For example, it may pointing to 11. Okay, so we have copied. We find its next, and for 11 we find its next. So the 7, the random pointer is going to point to 11, and 13, for example, originally it's pointing to 10. So the 13, the random pointer will, the copied 13 will random pointing to 10. So that is the step 2. That's the random connection. The step 3 is we trying to break this 7 to 7 and the 7 to this 13, but to connect back the 7 to 13. Let's use another color. So we connect back the 7 to the 13, and for this 7, we copy 7. We'll connect next to the copy 7, 13, and also we're going to break here, and let us 13 connect to 11 again, and the copied 13 going to connect to copied 11. So let's write code for this kind of method. So the same thing, if head equals null, we'll return head. We need to iterate the original node and create a copied original linked list. And for each node, we are going to have copy and insert that nodes after that. So we do the first thing, node. In L1 equals head. And node 2. Let's have 2 pointers equals. Let's put it is null first. While L1 doesn't equal to 1. We'll have L1 is L1. L1 doesn't equals to none. We need to create, let the L2 equals to new node L1 dot value to create a copy for this node. And we have L2 dot next equals L1 dot next. And L1 dot next will equal to L2. So, mm, and so we insert a node after L1. Now we move this pointer from 7 to 13. So L1 equals L1 dot next, because we already insert L2 in between. So it will be next dot next. So that's step one. We copy, iterate, linked list, copy each node and insert copied node after origin node. So this is step one. And let's do the step two. That is, we have L1 equals head again. And then now we need to L1 equals head again. Let me think. We need to update the random node. So I say while L1 not equal to none. I say L1 equals L1 dot next because we insert copied nodes. So when we iterate, we'll have next dot next. So L1 dot next, that is a copied nodes, but random, equals L1 dot random dot next. Yeah, so that is this copied nodes L1, this L1 dot next, it's random, will be L1 dot random dot next. So let this one to be connect. So this the second step, step two, that is connect copied nodes random. Random pointer. Then we'll do the step three, that we need to break separate, because now what we have is that L1, we have a L1 that copy, and we need to this is connect like this. We can use different color. For example, this is its copy. This is its copy. So we need to connect this back to this and this to this. So that is step three. Step three is that let's have L1 equals the head, and R2 equals the head dot next. Still, while L1 not equal to none. Let's say then could now assign node. Equals height L2 equals height next. Let's do this. Node new node new head equals head dot next. And L2 will be L1 dot next. So we are going to have L1 dot next. It's L2 dot next. So so L2 dot next. L1 dot next. L2 dot next. In a next L2 that connect back, and L2 if this one doesn't equal to null, that means if this one doesn't equal to null, that means we still need to connect this. So let's say if L1 dot next and equal to null, L2 dot next equals L1 L2 dot next equals L2 dot next. And we need to have L1 to move one step. To the forward L1 equals L1 dot next. So we just return new net. There is no exception because this is null. L1 done equal to null. Because this one is random can be null. So let's say if L1 got a random and equal to null, then we connect. Okay, for this kind of way, we have 3 steps. Have a copy instead in the original nodes next, and then iterate, find its random, and to connect the copied random reference, and then break the 2 linked list. For this method, it is also ON time complexity, but we don't use a map, so the space complexity will be O1.